Hi guys! Welcome to Unit 3, Lesson 2, Multiplying Fractions and Decimals. So today we're just focusing on multiplication. Two major properties of multiplication that are going to come in handy, not only during this lesson but in future lessons as well, are the associative property of multiplication and the commutative property of multiplication. Okay? And so I didn't go into great detail right here because you have this information in your lessons, but just as a quick review, associative property of multiplication means that you can move the parentheses to, or like you can group different sets of numbers, and if it's all multiplication, you still end up at the same answer, right? I can put the parentheses around B and C, or A and B, but eventually I'm still going to multiply by the other ones too, so I still get down to the same answer in the long run. Commutative property means the numbers can move. We can rearrange or reorder the numbers, and again, as long as it's all multiplication, then you're going to get to the same answer, all right? I know in my last video I used this example, A times B is the same thing as B times A. Or we could put numbers in there. We could say, I don't know, we'll say 2 times 6 equals 6 times 2, right? No matter which way I do it, I get down to 12 as my final answer. Okay? All right. With my first example, 3/7 times 9/10. So there's a couple things that we can be looking for when it comes to multiplying with fractions. One of those being, like, do any of my numerators have anything in common with my denominators, right? So we can pull out those common values ahead of time before we multiply, and it can make our lives a little easier. In this case, the answer is no. 3 does not have any common factors with 7 and 10. 9 does not have any common factors with 7 and 10. So I can't pull anything out, okay? I can't like pre-reduce it. So I'm just going to multiply. If you remember from 6th grade, okay, I know that was a little while ago, but 6th grade, when you're multiplying fractions, you just go straight across, okay? The 3 gets multiplied by the 9, and the 7 gets multiplied by the 10. So, get that multiplication chart out if you don't have these memorized. Otherwise, I hope you do have them memorized, all right? 3 times 9 is 27. 7 times 10 is 70, okay? And because I wasn't able to reduce over here, that also tells me I can't reduce over here. So in this case, this would be my final answer, okay? Not only that, both of them were positive. Remember those rules that we talked about in my last video? If the signs are the same, you get a positive answer. If the signs are different, you get a negative answer. Okay? All right, moving on. Number 2. Ooh, a decimal one. All right, for this one, we've got 2 6/10 times negative 1 1/3. All right? So there's a lot of things happening here, right? One, we're multiplying with decimals, so we have to remember all of those rules that we do with multiplying decimals, okay? But I also have different signs. I have a positive number times a negative number. So since my signs are different, I know my final answer is gonna be a negative number, okay? So you may be tempted to use the calculator, and that's fine, that's up to you. It's still good practice for us to do it on paper because let's say you're in state testing on, sometime in April, and they don't give you a calculator. Well, what are you going to do, right? You got to know how to do it on your own. So when we multiply with decimals, you do not need to line up your decimals. Mine happen to be lined up right now. That's okay. I'm not going to bring my negative sign down here because I don't necessarily need it to perform the multiplication. I already know that it's over here in my answer. So I'm going to ignore my decimal point for right now, and I'm just going to multiply these numbers like I would if they were whole numbers. So I've got 3 times 6 is 18. Drop my 8, carry my 1. 3 times 2 is 6, plus 1 is 7. I'm going to annex my 0 so that I can start multiplying with my 1. 1 times 6 is 6. 1 times 2 is 2. Okay, I've multiplied everything together. It's time to add them. 8 plus 0 is 8. 7 plus 6 is 13. Drop my 3, carry the 1. And then 1 times 2 is 3. I'm not done yet though. I need to put my decimal point back into my answer. I've got 2 numbers behind the decimal in my problem, so I need 2 numbers behind the decimal in my answer. Okay, giving myself a final answer of negative 3 3/38. Now let's say you're just like, man, I have no idea if I have that answer correct. Well, check it on a calculator, right? Let's see, we could do 2.6 times, and then we have let's see, I gotta learn how to use my calculator. 1.3 negative. Ooh, there we go. All right, look at that, it looks just like the problem I wrote. And then I'll put equals, and there's my negative 3 3/38. All right, perfect, we did it. All right, number 3, fractions. All right, once again, I have different signs. I have a negative times a positive. So what does that mean about my answer? Well, the signs are different, so then my answer is negative. Okay, now there's a couple things. Remember, I talked about, do any of my numerators have anything in common with my denominators? So I need to think, okay, can 2/5 be reduced? No, 2 and 5 don't have anything in common, so I can't reduce those. Ooh, but 2 and 10 do. So really, I could divide both of those by 2. Now the reason why I can do that is because that's like dividing by 2 over 2, which is really just equal to 1. So I'm not changing the problem, I'm just changing the size of the pieces. Okay, so I could rewrite this. Now if I have 2 divided by 2, and you've heard me say in multiple videos, whatever I do to my numerator, I've got to do to my denominator. Well, that's technically what I'm doing. I have 1 in the numerator, 1 in the denominator. So I could rewrite this. I could say, okay, well now 2 divided by 2 is 1. Okay, so I could rewrite that as negative 1/5 times, and then I'm going to leave my 3 as it is, but then 10 divided by 2 is 5. Okay, so I reduced it. And I've got a negative times a positive. I know I'm going to have a negative. And then once again, I just multiply straight across. 1 times 3 is 3, and 5 times 5 is 25, giving me a final answer of negative 3/25. Now, for those of you that were like, whoa, why on earth did you divide by 2? Okay, I'm going to show you the other way. Let's do it without reducing beforehand. I've got negative 2/5 times 3/10. Well, let's just go ahead and multiply straight across. I still have a negative times a positive, so I know my answer is going to be negative. 2 times 3 is 6. 5 times 10 is 50. Well, now, hopefully there's like red flags or, like sirens going off in your brain saying, ooh, 6 and 50 have something in common. They're both even numbers, which means they could both be divided by 2. And by dividing both of them by 2, it's really like dividing by 2 over 2, which is equal to 1. So I'm not changing the problem, I'm just changing the size of my pieces. So it's still negative, but then 6 divided by 2 is 3, 50 divided by 2 is 25. So both ways I got to the same answer. I just reduced at different times. I reduced up here beforehand or after. Now the nice thing about doing it before is like, what if these numbers were really, really big? and I wasn't able to like see something in common, sometimes it's easier to catch beforehand. So it's good to know how to do it either way. I hope this was helpful, and I hope it's helpful on your practice and your quick checks. As always, call me if you need me, okay? Have a great day, and I'll see you in live lesson.